Kirchoff's laws 3. What must be the EMF epsilon in the figure B in order for the current through the 7 ohm resistor to be 1.8 amps? Each EMF source has negligible internal resistance. So we want this current through the 7 ohm resistor to be 1.8 amps. Okay, so let's label the currents as the current going through the 3 ohm resistor I3, the current going through the 2 ohm resistor I2, the current going through the 7 ohm resistor I7. And I picked these directions for these currents as a convention, and let's see if it comes out positive or negative. So if I3 is flowing into this junction here, we can see that this will be plus minus, and this is minus plus 24 volts. So this is where the voltage drop occurs. And I2 is flowing into the junction, into this junction as well. This will be plus minus 2 ohms, and minus plus epsilon is the EMF of this battery. And then I3 plus I2 is equal to I7. This is basically the current going through the 7 ohms. Then this is plus minus the voltage drop across the 7 ohm resistor. So the first thing I did was basically look at this junction and write the Kirchoff current law for this junction. And basically that tells me the Kirchoff current law says the sum of all the currents entering a junction is equal to 0. If it is leaving, then it's minus the current is entering. So I2 is entering the junction, I3 is entering the junction, I7 is leaving, so this is equal to I7. So that's the Kirchoff current law equation. Now I'm going to look at this loop here and write Kirchoff voltage law. And basically I'm going to start at this point and end at this point. So this is my reference point for the KVL1 equation. So I'm following this loop in this direction. So basically I will start here and end here. Okay, so let's write KVL1 equation. KVL1 equation is basically so first I encounter this plus epsilon, so I have plus epsilon. Then I encounter this 2 ohm resistor, so this is going to be minus I2, minus 2I2, minus 2I2. And then I go here, I encounter this 3 ohm resistor, and I3 is flowing in this direction, so it is plus 3I3, plus 3I3. And then finally I have this EMF, which is minus 24 volts, minus 24 volts. So these should add up to 0 according to Kirchoff voltage law. So you can see that 2I2 minus 3I3, 2I2 minus 3I3 is equal to epsilon minus 24. So 2I2 minus 3I3 going to the right hand side, this gives me epsilon minus 24 equals 2I2 minus 3I3. Now I have another loop here, which is this KVL2, and again I'm going to start at this point and end at this point. So first I encounter this 7 ohms, so it is plus 7I7, and then I will have plus 2I2 minus epsilon equals to 0. So KVL2 is 7I7 plus 2I2 minus epsilon is equal to 0. All right, so I know I7 here, but I do not know I3 and I2, and I do not know epsilon. So there are 3 unknowns, so I need 3 equations This is the first equation, this is the second equation, this is the third equation. So I'm going to start solving these equations, substituting for I7 1.8 amps. So that's basically what we require. I7 is 1.80 amps. So the first equation is I2 plus I3 must be equal to 1.8. All right. And looking at the second equation, 2I2 minus 3I3 is epsilon minus 24. So let's write that here. 2I2 minus 3I3 is equal to epsilon minus 24. And then I have 2I2 minus epsilon plus 7I7 is equal to 0. So that gives me 2I2 is equal to epsilon minus 7I7. So the KVL2 equation, 2I2 equals epsilon minus 7I7, so 7 times 1.8. That gives me epsilon minus 12.6. All right. So I can substitute this for 2I2 into this equation. So I can go up here and substitute this to the equation I obtained from KVL1. So that gives me epsilon minus 12.6, which is what I'm substituting for 2I2 here, minus 3I3 is equal to epsilon minus 24. So these epsilons will cancel, and I can rewrite this as 3I3 is equal to, this 24 will go to the left hand side as plus 24, 24 minus 12.6. So that gives me I3 is equal to 3.80 amperes. I can substitute this result for I3 into the Kirchoff current law equation, this equation, and that gives me I2 plus I3, which is 3.8, is equal to 1.8. So this means I2 is equal to minus 2 amps. All right. So 2I2 was equal to epsilon minus 12.6. That is this KVL2 equation here. So 2I2 I can write as minus 4. That is equal to epsilon minus 12.6. So this tells me that epsilon must be equal to 12.6 minus 4. So epsilon should be equal to 8.60 volts. All right. Now that we have an answer, let's check it using this grand loop here, KVL3 loop. And let's again start at this point and end at that point. So first of all, I will encounter 7I7. Then here I will encounter 3I3. And then I will encounter minus 24. This must be equal to 0. So let's see if that's the case. So KVL3 equation, this is just to check the result. 7I7 plus 3I3 and minus 24. this is basically, this should be equal to 0. So let's write what is 7i7. So it is 7 times 1.8. What is 3i3? 3 times 3.8 minus 24. And this is equal to, is this 0? So this is equal to 12.6 plus 11.4 minus 24. So I obtain 0. So this basically shows me that the value I calculated for I3 is correct. Therefore, this is one way to check if that calculation I have done was correct. And basically, I can see that this answer should hold. Okay, so in this problem, we have a circuit that consists of 3 resistors, 3 ohm, 2 ohms, and 7 ohms. On one branch, I have a 24-volt battery. On the other branch, I have an epsilon EMF source with epsilon EMF. And I want the current through the 7 ohm resistor to be 1.8 amps. So I want to know what should be the value of epsilon. So first of all, I write Kirchoff current law. The sum of all the currents entering this junction, I3 plus I2 minus I7, because I7 is leaving, is 0. So that's the first equation. The second equation is KVL 1, Kirchoff voltage law 1. I start at this point, and I see that I2 is flowing in this direction. So first I will encounter epsilon. So I start with epsilon minus 2i2, then I have plus 3i3 minus 24 is equal to 0, second equation. Third equation, because I have 3 unknowns, KVL2, I start at this point, I have 7i7 because I encountered the plus first, and then 2i2, and then minus epsilon is equal to 0. That's KVL2 equation. Solving these equations simultaneously, noting that I7 must be 1.8 amps, I find I2 to be minus 2 amps, so this was not actually correct. I2 is leaving this junction. And I find I3 to be 3.8 amps. So I note that I have these results here, intermediate results, and I can use these to calculate epsilon from the KVL2 equation. Basically, that gives me epsilon equals 8.60 volts. If I follow this grand loop, 7i7, 3i3 minus 24 equals to 0, that also gives me 0. So that basically is going to check if the I3 value I calculated is correct here. So that seems to hold. So that's one way to get more comfortable with this result.